Hello, everybody. Welcome to join today's webinar. My name is Bo. I'm ScreenBeam field application engineer. I based in Sydney, majorly responsible for Australia and the New Zealand market. Today, I will spend some time to share some experience for how to connect Apple, Android, and Chrome devices to ScreenBeam receiver. And what's the typical issue you guys will hit during implementation, and how to do the troubleshooting, how to fix the issue. Apple device depends on native screen mirroring to connect to the ScreenBeam receiver. You don't need to install any additional applications in Apple devices. Everything is native to Apple device. So from MacBook, there's a AirPlay icon on top of the menu. You just click that icon, then it will begin to search for the available receiver to connect. If you are using iOS device like iPad or iPhone, you can swap down from the right top menu and go into the control center and click the screen sharing. From there, it will start to search the RF space and search the network to find out which ScreenBeam receiver is available for you to connect to. So this search actually is based on MDNS protocol. So you guys need to remember, you need to enable MDNS protocol between the Apple device and the ScreenBeam receiver to enable the Apple device to find the receiver. So after the Apple device found the receiver, you just need to click the receiver name, and it will pop up for you to type the PIN code. After you type the PIN code, we'll do a series of authentication and negotiation to build up the RTP and RTSP session. Then finally, you are able to connect to the receiver and stream whatever in your local laptop. So this process is quite straightforward. So it's a bit different than our earlier solution, which depends on some Apple ScreenBeam cast applications. So to enable the Apple device to successfully connect to the receiver, the first thing you need to do is that you need to enable this feature, this Mac OS and iOS native screen mirroring feature in the receiver's configuration. So if you guys are familiar with the configuration of the receiver, then you can see this picture here. You just need to log into the configuration page, then click the features tab, then scroll down to wireless display overlap. Under that, you can see there's one option called Mac OS native screen mirroring. So you just need to check this and to enable this feature. As I said, in early days, we also have some SVCast application to be installed in the Mac OS, and also some legacy devices like Windows 7 to enable those devices to connect to the receiver through the network. So that's the second line. You can see Mac OS or Windows 7 that can be checked as well. But recently, especially with our new model of the receiver, we strongly suggest you guys just use this native screen mirroring. Don't use that application, because that application, firstly, you need to install that and waste a lot of time. Secondly, the performance is not so good as compared to the native screen mirroring. Not all the model of ScreenBeam receivers support the Apple device. You guys need to remember 960 and the 1000 series receiver, only those models are supporting native screen mirroring and can be able to connect it to the Apple device. And also from the firmware point of view, 960, you must be upgraded to at least 9.15.39.0. Otherwise, there's no option for you to enable the Mac OS native screen mirroring. For all the ScreenBeam 1000 model, they all support Apple devices. The newest version is 11.0.8.0. So whenever you try to test it or just begin to use it, we strongly suggest you guys to update the receiver's firmware to the newest available firmware. From Apple device point of view, there's also some requirement regarding the system spec. Just to make sure your Mac OS, MacBook, your iPad, your iPhone, their OS not too old. So just meet those requirements. I believe most of the current, MacBook and iOS device support this. Another important thing is that due to this Apple connection, actually it's based on the network connection, not as our traditional Windows 10 Miracast, which is point-to-point connection. Apple device must go through the network infrastructure. So you need to make sure the receiver's IP address and the Apple device IP address, they need to be able to ping each other. They can talk to each other. Sometimes, we found some of the customers, they connect the Apple device or ScreenBeam receiver to a guest WLAN. And a lot of guest WLAN security policies, they don't allow peer-to-peer to communicate. So they just block everything between, if you try to communicate to the peer devices. So you need to check with your network admin to make sure this one, and they should not block this. And as I said initially, MDNS is a protocol used for the Apple device to discover the receiver. And some of the customers, they don't want MDNS packet to be sent across their network. So they have very strict security configuration on MDNS. So make sure you talk with your network and the security admins and tell them what need to be enabled. So MDNS basically is a multicast protocol. It uses 224.0.0.251 as the destination IP address. UDP port is 5353. And this is a link local protocol, which means they can only, by default, they can only be sent in the same IP subnet, same VLAN. So if your receiver and the Apple device are located in different IP subnet, different VLAN, you need to make sure the layer 3 gateway between these two subnet, they have been correctly configured to forward this MDNS packet. A lot of companies like Aruba or Cisco in their wireless WLAN controller, they have concepts like Air Group or MDNS service group, those kind of things. So you need to check with the network admin, make sure they modify their existing Air Group or MDNS or service group configuration to include the receiver's MAC address and also the Apple device into this group, because they use those groups to control where the MDNS traffic can be sent. Only the MDNS group member can receive those packets. So just make sure, check that. If, especially in some small company or primary school, they have very weak, IT resources. For example, they outsource their IT to a third-party company. In that case, it's very difficult for them to check the network security configuration and make any configuration change. In that case, we strongly suggest customer can select our 1000 series receiver, because this receiver have a local Wi-Fi, embedded AP inside the device itself. So those Apple devices, they can easily connect to the SSID broadcasted by this local Wi-Fi. So they can directly connect to this ScreenBeam receiver, bypass the network infrastructure. So you don't need to change anything in your existing network infrastructure. So that makes things very easy and very easy to implement and very easy to maintain. But only ScreenBeam 1000, 1100, 1100 plus, those 1000 series new model support this feature. So keep that in mind. Service ID are also a very important thing, because like Aruba or Cisco, different company, when they implement MDNS, they always have parameters to be configured. For example, the Aruba, if you configure Aruba controller in their Air group, they should include the service ID. So here listed all the service IDs our ScreenBeam receiver using. So make sure these service ID have been added into the related network device. Apple device, they actually depend on a lot of UDP port and TCP port before you can build a reliable connection between the Apple device and the receiver. So here listed all the ports used by the Apple device. So you also, if you got firewalls between the Apple device and the ScreenBeam receiver, make sure these ports are being logged in the firewall. So what's a common challenge when you connect Apple device to a ScreenBeam receiver? The first thing we often hit is that a lot of customers complain when I connect my MacBook into the network, I just cannot find the receiver. I click the AirPlay menu, but I didn't find anything there. So this one normally is caused by either client isolation or MDNS. Right? So if you found that if the Apple device cannot ping the receiver, so that means it's a client isolation issue. If the Apple device can ping the receiver, but still cannot find the receiver, then normally it's the MDNS issue. So you should check the network configuration, make sure MDNS is correctly configured, and the MDNS traffic can be forwarded across the network boundary if the Apple device and the receiver are in different IP subnet. So after the ScreenBeam receiver being found by the Apple device, when you click the name of the ScreenBeam receiver, try to connect to it, and sometimes it will fail, right? So this issue normally happens in the background if there's some security application running, like MDM, Apple's mobile device management policy. So some of those mobile device management policy will require ping on every AirPlay connection. So when the issue happens, just check that policy. Make sure you disable that policy requiring ping on every connection for iOS. So after the Apple device connect to the receiver, then another common challenge is that some of the end user may complain, I have poor performance. I found it's a long delay. The picture is not synchronized and the voice is jitter, right? So how to do the troubleshooting like this? This one is very, very challenging in a complicated network if you are using the traditional 960 receiver, because that one fully depends on the existing network infrastructure. So for this kind of issue, first of all, you need to get a very detailed network diagram between the Apple device and the receiver. Not just the general high level, pictures, let's say, oh, that's got a one switch, AP, Apple device. That is far more than enough. You need to get a very detailed information. For example, the name and the device type. For example, if this is AP, if this is layer 2 switch, or if this is a layer 3 switch, and what's the port, especially the trunk port, the interconnection port between them. You find out the port number and the port type. That's another thing is definitely you need to know what's the IP address range and the VLAN in this diagram, because as I said, no matter it's MDNS connection or the RTP, RTSP connection, they all depend on this IP communication. So you need to clearly find out what's the IP and the VLAN of the Apple device, what's for the ScreenBeam receiver, what network equipment are between them. Then you need to log into each interconnected network device to check several things. First, check if any device have high CPU utilization rates. In some shared network, sometimes either due to the design is not good enough. For example, they didn't consider some peak traffic. All the device have some bugs, right? So a lot of times you will find that some of the device, for example, a layer 3 switch that have a very high CPU utilization rate, so the forwarding speed are very low, so which causes the expected packet cannot be exchanged between the Apple device and the ScreenBeam receiver in time, which will cause a long delay. And also another thing, you should check the interconnection port to see if there's any packet drop, no buffer or some whatever errors you can find from the port. Enterprise level AP double-line controller like Cisco's AeroNet, they have those capabilities. You can they have a command to show you very detailedly in each port what's the packet type it found and what's the statistic for that and how many errors you found for that. It's easy for you to find. But I do find that in a lot of primary school or private school, they're using some cheap network device, especially those cloud managed device. They just give you some very general information. For example, you can find out who's connected and how long time it's connected, but it cannot show you what errors happened in each port or each double-line, each SSID, each radio channel. So those information actually need the network engineer have advanced technology to find out those information. So keep that in mind. If you guys cannot find those things, for example, some is due to the engineer not have the capability. Sometimes it's due to the network device is low end. They just don't support those advanced feature. So in that case, will cause the troubleshooting very difficult. So that's why we strongly suggest, before you guys suggest implement this solution in a customer's real network, find out if their network is complicated or not. If their network device is advanced enough to support those features, find out if the end customer, their technical skills is good enough to support this. Because if one of them is not there, you just found out, okay, customers complain, not working well, but you just cannot find out why. Simplest isolation you can do is you connect both the receiver and the Apple device to one AP. Make sure only these two devices connect to the AP. Sometimes customer tested, but because their AP shared by a lot of different students, different members. So with one SSID, too many guys are using that. All of them just competing for the bandwidth, which definitely will cause some delay in some peak hour. So to narrow down it, find one AP, only get the Apple device and the receiver connect to this AP in the same WLAN and test it if you still see the performance issue. If not, then definitely it means it's a network issue. So you need to log into each network device and troubleshooting accordingly. And I do find out a lot of times customer, especially for those cloud-based measurements, they didn't configure any network QoS to guarantee the wireless display traffic at high priority or enough bandwidth. Because if you want to get a stable, high performance, wireless display experience, for 960 series, normally the required bandwidth is 2 meg to 10 meg end to end. All right, that which is depend on the resolution. And if you are using 4K 30 Hertz, then the peak bandwidth requirement could be up to 20 meg. So if this is just a AP one channel shared by multiple users, for example, the channel is just like 300 meg peak rates, but if you got like 20 or more people connect to the same channel in the same time, then if somebody is doing something to download a huge file or watch some video, which will cost available bandwidth for the wireless display is not enough, then will cause the issue. So here's some useful links for you guys to reference in future. So when you connect from different devices to the receiver, what's the command and what's the things you need to take care of. So you can check that later. For Android device actually Android device have two kinds. One is that they have native Miracast embedded in the system, so you can directly using the Miracast to connect. Secondly, if for some reason there's no Miracast available or have some limitations, bugs on that part, you can still using Chrome, Google's Chrome feature to do the cast from the Android device to the receiver. For Chromebook or Windows 10 or Apple device which is running with the Chrome browser, then you can use the Chrome browser feature. That's a feature called cast in the Chrome browser. You can use that to cast to the receiver as well. For Android device, there's some important information you guys need to remember. First of all, for the Android OS, at least 4.2, but we recommend to use 5 and above. Some legacy Android phone, those cheap phones, they even have more limitation on that part. Remember one thing, Google's Pixel, they don't support Miracast. They only use Chromecast for mirroring. And also remember that a lot of times the customer's phone actually is get from a vendor. For example, in Australia, they get from Telstra or Optus. So different ISP, they have different customized Android OS running on the phone. So some of them have a good support of Miracast, some have poor support. For example, some of the features they don't support, like ping, those kind of features they don't support very well. So you need to make sure you you check those, not just give you an impression that, okay, my Android phone OS is for example, version 10 or version 9. I should support that. So remember, some of them, they just customize the Miracast in a different way, so cause a different compatibility issue. Some cheap entry-level Android phone, they don't support DCM, a different channel mode. So this is a requirement for the receiver to work in the AGO mode. So which means you're using one physical Wi-Fi card, you build out two logical connections. One connection is to your network infrastructure. Another one is for the mirroring between the Android phone and the receiver. So this is called different channel mode. So some cheap phone don't support this very well. So in that case, you have to change. If you have to support this kind of entry-level phone, then you have to change. You probably have to change the receiver's P2P working mode from default AGO to the NGO mode. And sometimes, especially for those enterprise customers, they like to run some VPN software in their phone. So far, a lot of VPN software don't support Miracast. They just treat that as host connection, so they block that connection. So if you found that you cannot Miracast from your Android phone to the receiver, and you found there's a VPN running there, you should remember you can verify that by just temporarily remove that VPN software from the phone and test if it can work. But so far as I know, most of the VPN software for Android phone in the market, they don't support Miracast. So in that case, you should choose different way. We will discuss that in a later slide. One of the frequently happening issue, for example, for Samsung, some old Samsung like S3, S4, they don't have good supportability for ping. They only support PBC. So in that case, for example, if you don't know if your Android phone support ping or not, or even it gives you option to type the pin, but you found that after you type the pin, the authentication still fails and cannot connect. You can try to log into the receiver to disable the pin. So basically, it's in the features tab, you scroll down to security setting. So there's an option called false pin pairing. You can change it to off. So after you change that, I test with that phone again to see if it works or not. We also found some Android phone, they have some issue with fast IP. So I don't know if you guys know fast IP, but in summary, it's just a process to get the to fasten the IP connection. So we found that some of the Android phones they firstly will use fast IP to get IP address, but it mistakenly used DSCPD to get another IP address, which caused the confliction and caused the mirrorcast to fail. So the workaround is that to disable the fast IP in the ScreenBeam receiver. And for those Android phones who cannot be worked around by what we mentioned earlier, for example, VPN, the customer said, oh, I must use a VPN software in my Android phone because I need to connect to my company, right? So if they cannot disable, how to do that? Workaround for this Android phone is that you can use Google's Chromecast. So depends on your Android phone's model, they have a different name for that. For example, you can just go to Google Play Store in the phone, just search for Screencast, and then you will find available software and download in the Android phone. You can use that software to cast to the receiver. For Google Cast connection, there are also some key points you should keep that in mind. So far, only ScreenBeam 1000 series model support this cast feature. So it's also under the wireless display over LAN. Under that page, there's an option to enable Google's native screen mirror. You just need to enable that. Secondly, the Google Cast Protocol actually is they require network connection. So the receiver and the Google Cast client, they need to be connected to the same network, not different network, because everything happening in the same network. They don't support across the network network boundary. Similar to Apple device, they depend on the MDNS to do the discovery. So you need to make sure the MDNS is enabled in this network so that the Google client can find the receiver through this MDNS process. The port number and all the process are the same like Apple. The receiver itself also need to have an internet connection because during the initial setup, the Google require to synchronize with their servers in the cloud. So you must have an internet connection. Otherwise, you just cannot connect with it. So here's a place to enable Google Cast, the native screen mirroring, right? So log into the configuration page of the receiver, click the features tab, scroll down to wireless display over LAN, and enable that Chrome native screen mirroring. So here's also some useful links for you guys to check later. So it provides a lot of useful information when you try to connect those different kind of Chromebook, Android device to the receiver. So here's my contact detail, my email address, my phone number, and also I include Albert's contact number here. So in the future, if you guys hit any technical issue, don't feel hesitant to contact us. We are happy to service you guys. So that's end of my presentation today. Now we have 10 minutes for questions. You guys can type your questions in the chat menu, so we can answer it.